Alright folks, we are working on part 2 of section 3.4. So we're starting at page 9 of the chapter 3 notes at the very top. We have example 3 here. It says it wants to classify the triangle by its sides and by its angles. So we need two vocabulary words here. One that's going to classify this by sides, one that's going to classify by angles. We just got done talking at the end of part 1 about classifying triangles by sides and by angles. If you look at the previous page here, we talked about classifying by angles and classifying by sides. So that's what we're looking to do here for example 3. So it's a fairly simple process, so why don't you pause the video here and write down one word to classify by sides and one word to classify by angles. Alright, and we're back here. We're going to classify this thing by sides. We have two equal sides, if you see by the congruence marks right there. So if you have two equal sides, that is going to be an isosceles triangle. And when you go to classify by angles, you see we have a right angle here, two acute angles. So when you have one right angle, that is a right triangle. So this is a right isosceles triangle. It doesn't matter if you have the word right comes first or second, it doesn't really matter as long as you have right and isosceles there. Okay? Example 4, I want you to draw an example of each kind of triangle. If it's not possible and it can't be drawn, just write not possible there. So again, we're going to get you to pause the video here and draw an acute scalene triangle right here, an acute isosceles triangle here, an obtuse equiangular triangle here, and if any of them are not possible, just go ahead and write not possible. So you can pause the video now and take care of that. Alright, so let's see our answers here for acute scalene. This is actually a much trickier triangle to draw than you might think. Acute means all three angles have to be less than 90, and scalene means you have no matching sides whatsoever. So let's see if we can draw this here. We want that to be an acute angle there, and we can't draw this so far that's going to make this angle here be a 90 degrees or something greater than 90. Okay, so we want this to be shorter. You want that to be shorter. In fact, that's not even that great here because that's very close to being 90. So you need to draw something that is less than 90 degrees. So let's see if we can't do a better job on that last side. Right, so you have three different sides here, no matching sides whatsoever, all three angles less than 90, even though this is very close, you have to be very careful there. And we have an acute scalene triangle. If you need to do that in a quiz or test, just make a note, no equal sides, no angles, or all three angles less than 90, and that's good. The fact that that's super close there, I would be grading what you write and not necessarily what you draw. For the next one, we want an acute isosceles triangle. So isosceles means you need to have two equal sides. So maybe if the triangle is going this way, you want to have two matching sides there. And acute meaning you need to have all three angles less than 90. So we're in good shape there. And it doesn't matter. Your triangle could have been sitting up and down instead of going sideways. As long as you have two matching sides and three angles that are less than 90, you're in good shape. For the last one here, obtuse equiangular. Obtuse means it needs to have one obtuse angle. And equiangular said it has to have three equal angles. Well, obtuse is bigger than 90, and if you have angles that are bigger than 90 and you try to add three equal angles that are bigger than 90, you're going to get something that's way bigger than 180 degrees. So this one right here is not possible. Even if you draw a really small obtuse angle like 91 degrees, and you have to do that 3 times because they all have to be equal angles, so it'd be 91, 91, and 91, you'd already be way over 180. In fact, you'd be over more than 270. So the last guy there is not possible. Moving on here, we got exterior angles, right? So this is probably a new idea. An exterior angle, you might guess, is going to be on the outside of the triangle. So out of 1, 2, and 3, angle 1 is our exterior angle. So we're just going to draw an arrow to it and point to it. And then something over here, remote interior angles. Well, interior is going to be on the inside of the triangle, as you might guess. And remote, though, is a new word. Remote usually means far away or from a distance. So remote has to be from the perspective of angle 1. It has to be the interior angles that are far away. So even though this right here is an interior angle, it's not going to be a remote interior angle because it's right next to that angle. It's adjacent, right? So our remote interior angles are going to be angle 3 and angle 2. And that would change. If I happen to have drawn my exterior angle over here, then 2 would be right next to it, and my remote interior angles would be 3 and that angle there. So when you're talking about remote interior angles, you always have to know from what perspective you're talking about. From what angle's perspective are you talking about? And the whole reason why we have those new ideas is because here they are used in Theorem 313, the triangle exterior angle theorem. So here you have one line of the triangle drawn as extension to create an exterior angle, and 2 and 3 are the remote interior angles. So what this theorem tells you is the measure of angle 1 is going to be equal to the measure of those 2 angles added together. So the measure of the exterior angle triangle equals the sum of its 2 remote interior angles. Right, so what that's saying is if you want to know the measure of angle 1, that's going to be equal to the sum of the 2 remote interior angles. So if this is 12 degrees and that's 10 degrees, then that one's going to be 22. Obviously that's not the case because one's obtuse, but you get the idea. Right, example 5 says find each angle measure. What you want to do is figure out how big angle 1 is and figure out how big angle 2 is. Now keep in mind, angle 1 is a remote interior angle. Or excuse me, angle 1 is an exterior angle. Angle 2 is not, it's on the inside. So you're not going to do these 2 problems exactly the same way. You're using this idea here that we just learned, but you're going to do slightly different because your variable is going to be in a different spot, because one time it's going to be the exterior angle, one time it's going to be one of the interior angles. So pause the tape here and figure out how big angle 1 is and angle 2, and we will describe it in a minute. Alright, so let's take a look at the first one. 1 is an exterior angle, so following this idea here, the measure of the exterior angle, in this case angle 1, is going to be equal to the sum of the remote interior angles. So 20 and 35 are interior because they're on the inside, and they're remote because they're not right next to angle 1. They're not talking about this angle here, they're talking about the other 2. So we're going to take those 2 numbers and add them together. And so the measure of angle 1 must be 55 degrees. And if you put 55 there, you could figure out how big this angle is because they're adjacent, and then you could check yourself by adding those 3 numbers to make sure they get 180, that it would work out just fine. Over here, we mentioned a minute ago that this is going to be set up slightly different because you're not looking for the exterior angle this time. The exterior angle is given to you. So over here we said the exterior angle equals the sum of the 2. So here the exterior angle is equal to the sum of the other 2. Well, we don't know what this one is. It's the measure of angle 2. And the sum means we're adding it to 25. Alright, so now here your mystery number is on the different side of the equation. And we're trying to get measure of angle 2 all by itself. So if you subtract angle 25 from each, or subtract 25 degrees from each side, you get the measure of angle 2 is equal to 95 degrees. And you can check yourself by putting 95 there, adding those 2 numbers, make sure you get 120, and it all works out. Right, that wraps up section 3.4. And you can see next time here we're going to be dealing with section 3.5, which talks about the polygon angle sum theorems. Right, so we will talk to you later.